Hi there. We're on P8.2 Lesson 1, Linear Equations. The first thing I want you to do in this lesson is to go to the visual notes and look over the very first part of solving equations using models. There's a few examples and pictures of using a balance scale. It's a pretty simple concept, so I left it out of this lesson, but I do want you to go through it because there's a few questions in the assignment on it. Alright, so we're going to start with modeling equations using algebra tiles. This is your variable tile, x, and yellow means it's positive. Again, variable tile, negative x, red means negative. Here you've got your single tiles at positive 1 and negative 1. Those are your integers, or your numbers, I guess. And this is what it's going to look like. So, Jody's a contestant in the Esther Hazy School Spellathon. A contestant receives 3 points for every word spelled correctly, and because of a technical penalty, Jody loses 5 points. She now has 19 points. So we want to find out how many words has she spelled correctly. So we're going to let J represent the number of words Jody spelled correctly. We're going to use a J because of Jody in this case. More often than not, you'll see an X instead, but I just wanted to show you that it could be any letter of the alphabet. And then the number of points she received is 3J because she got 3 for every word spelled correctly. And then the penalty has to be considered, where she lost 5, so 3J minus 5. And how many words did she spell correctly? We're going to find that by knowing that 3J minus 5 was 19 points. And now we can get into how we're going to solve this. Okay, we're going to use algebra tiles here. I have them all laid out ahead of time because they take a little bit to place. So x in this case is j, right? So we've got 3 variables, okay, laid out, positives, and 5 negative ones, right? Because we've got a negative 5 here. And then that's equal to 19, so I've got 19 yellow ones because they are positive. So now what do we do with this? What we have to do is get our variables into positive mode. So in order to do that, I'm going to make some 0 pairs. These negative tiles here, negative 1. So I need 5. Okay, and what I do to one side of the equal sign, I must do to the other. So I got to drag 5 over here as well. All right. Okay, and 0 pairing them off means that these all pair up, right? And that means that they're gone. I'm actually I would draw an arrow gone for all these. So that I'm just going to actually cross them out like this. So now I'm left with 3 of these and 1, 2, 3, 4, 5, 6, 7, 8, 24 of these. And what this tells me is I can group these. So this is a group because they're equal, right? This is a group. This is your middle group with this tile. And your top group. Okay, so I can look at this as 3J, 1, 2, 3, J equals 24, but I'm trying to get that single J by itself. So 1J, I'll write the 3J. 3J equals 24. Okay, we can see that. But I want just the only single J, and I know it's equal to, counting these up, 8. So I have found my solution. Jody spelled 8 words correctly. Okay, so now in the assignment, it's going to ask you to verify your answer. Now in order to do that, you have to, I did lay this out ahead of time because drawing all this takes a lot of time and make for a long video. Okay, so this was the initial, right? 3J minus 5 equals 19. So we now know that J equals 8, right? So I changed the variable of this to 8 of these. Okay, and that negative 5 still stuck around. This stayed the same. Okay, but I did need to still get rid of these. Okay, so I would 0 pair them out. So I would drag, no, I got my pen on. I would drag 5 yellow down, and then these would cross out, and then we'll drag 5 yellow over here. Let's just pretend these are yellow. Make it a little bit quicker of a video. Okay, and then I would see that this side equals this side, and that would show me that this is indeed correct. Okay, and if this is too fast or confusing, it's all laid out in your visual notes as well. Okay, I'm going to do one more example here where it's set up a little bit different. It's kind of flipped. That sometimes confuses people and has some more negatives in it. So here we've got 8 equals -6 minus 2x. So I've got my tiles all laid out. I need to make the variable tiles positive. So in order to do this, again, remember these are the variable tiles, I need to add 2 of these. And what I do to one side, I'll do to the other again, right? And that's going to 0 pair these out of there. And I'm going to be left with it looking like this. Okay, again, I need to get these variables by themselves. So I need to 0 pair out. So I need to drop down 8 of these red. Make this a little messy, sorry. Oops. To get rid of those 8 yellow, correct? Everybody's following, hopefully. So it needs to be done over here as well. So I'm going to pull down 8. 4, 5, 6, 7, 8. All right, so now these are gone, and we'll have 2x equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. -14. Okay, and those can be divided into 2. Those -14 into -7 each, right? If we group them. So these are gone. These can be grouped into 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So x equals -7 because they're red, right? 2 of these x's are equal to all of these, which is -14. So I found my answer. Now again, you could verify this like I did the last one. That also is in your visual notes. So if you want to go see how that was done, if you need an example for your assignment, it's okay. We're going to move on to just doing algebra without tiles. So I did draw this line just as kind of an example of what it looked like with the tiles. But you can see now what's going to happen. You still want to even out your equation, balance it, sorry, better term. So what I need to do here is key on the variable. I want to get it by itself, just like I did before. And in order to do that, I got to get this number out of there. So I want 3x by itself. In order to get rid of 15 and make it 0, you got to subtract 15. I'm not going to write plus 15, subtract 15. Okay, I'm just going to know that I'm doing this. And what I do to one side, I'm going to do to the other. What I often show my kids in class is just to do this. And then rewrite it like this. Okay, so now I've got -3x equals 30 minus 15. So I've got -3x equal to 15. I don't like this line a whole lot, but I'm going to keep it there. And now we go back to our integers unit and how to get this by itself. We're going to go and put -3 because we want x to be equal to 1. 1x always equals x. It's a bad x. Okay, we don't write it like this. We just write x by itself. Okay, so -3, what I do to one side, I do to the other. So this is gone. X equals 15 divided by -3. Remember your rules of dividing integers, and we've got -5 as an answer. Then when it says verify, that means you plug it back into the original equation. So I'm actually going to rewrite the original equation. And oops, it's a 30. I'm going to substitute x in there. The answer I've got was -5. So I'll put that where the x is. I'm going to put it in a bracket because it's multiplying when it's side by side like that. -15, or sorry, -3 times -5 is positive 15, plus 15 is 30, and my sides balance out, so I know my answer is correct. This is what I love about algebra. You can check your answers. Okay, let's do another one here. No lines in the middle, just equal signs. I need to get this variable by itself, so I'm going to subtract 7 from both sides. I will write out that first step. Okay, remember your addition and subtraction rules here. -9 subtract 7 is -16 equals 5x. Divide by 5, I want that x on its own, and now it's like, oh gosh, this is looking ugly. But we're going to leave it just like that. And now we're going to verify or check. So I'm going to rewrite the original again. Oops, plus, pardon me, 7. -9 equals 5 times, I'm going to put that bracket, -16 over 5 plus 7. Don't panic, you know how to do this. -9. We're going to look on the diagonal here, right? This is the same as 5 over 1. So we're actually going to cross this out because those two are the same. And we're going to get -16 plus 7. And -9 does equal -9. So it is correct. If we're going to go -16 times 5, we would have got that answer, then divide by 5, we're going to get the same answer. Okay, so that's why I crossed those out, because we can look at that diagonal. That again comes from the integers unit. So there we have that, and let's move on to one more step involving fractions. Okay, so here's a real life question. The school SRC sold t-shirts for charity. The council bought the t-shirts in a box of 40. The SRC added $6 to the cost of each shirt, and each t-shirt sold for $26. What did the SRC pay for one box of t-shirts? So let C dollars represent what the student council paid for the box t-shirt. The cost of each t-shirt the student council bought was C over 40, right? Because there was 40 per box, plus they added $6. So each t-shirt sold for $26, and this is your equation. C over 40 plus 6 equals 26. Now let's solve it. Okay, so now we've got fractions in there. Not a big deal. Same rules apply. I want to get this variable by itself, so I'm going to subtract 6 from each side. Let's do that step first. Okay, keep C over 40. 6's are gone. 26 minus 6 is 20. All right, now in order to get C by itself, I need to what? Multiply by 40 over 1. Right? So if I do that, I've got 40C over 40. So I get C by itself. Again, what I do to one side, I do by the other to the other. And 40 over 1 is the same as 40. You can put the 1 there if you want, but it's not necessary. And 40 times 20 is 800. Sorry, that's a 0. Okay, so that means that there was 800 shirts in each box. Now, we can totally check this because it will ask us to. All right, so let's go 800. I'm not rewriting the original this time. Over 40 plus 6 equals 26. Does it really? 40 goes into 800 how many times? 20 plus 6 equals 26. So yep, there was indeed. Okay, so this covers all 3 sections and should get you to where you need to be. Make sure you look at the examples if you need to in your visual notes, and I'll see you in the next lesson.